Great. Welcome, everybody. We have Konstantin here from Protocol Labs. He's going to give a session on IPFS and Filecoin and how it shapes the future of Web3. Feel free to add your questions to the chat and we can take them towards the end. Konstantin, I'll let you take the stage.
Thank you a lot. And welcome, everyone, from Protocol Labs side. I am super excited to be here on Hackathon event, and the next 30 minutes will be just amazing. So first of all, welcome you here on the session Introduction to IPFS and Filecoin and how they shape the future of Web3. So to clear things up, first of all, we are quite a huge organization. You may know us under different names, but we work with a community of people and organizations to build a better future through technology. So you may know Protocol Labs, which is an open source R&D lab, which is aiming to build protocols, tools, and services to improve the internet. We also have our branch, which is called Filecoin Foundation, which are the stewards of the Filecoin community and aspiring to put the power of humanity, most important information, back to the hands of everyone. And most likely, some of you are already familiar with such protocols as IPFS, which is a peer-to-peer protocol, making the web upgradable, resilient, and more open, and Filecoin, which is the largest Web3 decentralized storage network that stores humanity most important information. And today's session would be consist of 5 items, which first I will go through the core concepts of IPFS and Filecoin. Then I will showcase you the tools for builders. Then I will provide you some ideas for your hackathon project, if someone of you is still deciding or developing your project idea. Then I will talk a little bit more about the possibilities of Web3, and then I will proceed with a discussion and Q&A to answer the questions you have right now. So feel free to also add all the questions to the chat right now, and I will try to cover them all once I finish the main session. But drop your questions at any point of time. And coming to the topic of the core concepts of IPFS and Filecoin, this is the development of the internet. This is how our history progresses, how we interact with the web. First, we started with the read-only internet. Then there was a read and write, the web 2.0, which you are most familiar with. And we are slowly going towards Web 3. I will not go into too much details what exactly Web 3 is. Let's just suffice that it's the next evolution of the web. It makes web read, write, and trust, where trust is being an operative thing. And there it is achieved through verifiability and a whole bunch of underlying primitives and technology that builds up to it. So we are all on these 2 major sides, transitioning from Web 2 to Web 3. And Web 2 in our case is very centralized, very disconnected internet with many single points of failure, with data monetization by the data monopolists. And we are trying to transition to a more decentralized and ideally distributed internet. And by distributed, I mean the internet where users power the services, the internet which is censorship resistant, which considers your privacy on the first place, and at the same time, the internet which is self-verified and non-siloed data. And how do we get to this amazing internet of the future, which is on one side is resilient, performant, scalable, secure, efficient, and many other major words about how internet should be structured. But this all is in our history show that being centralized and being single point of failures is always worse than being open peer-to-peer and communicated all across the network. And as we proceed to exploring the Web3 stack, many of you are already developing some of the solutions for the Web3. I would say that for the Web3 stack, verifiable data is one of the essential points to a truly distributed system. On the image below, you see that there are many parts that compose Web3 stack together. You have the layer 1 chains, you have side chains, you have development environment and file storage, and many more pieces that come together to create a Web3, which is resilient and accessible for everyone at any point of time. IPFS and Filecoin also contributes to this Web3 stack. And not only we are highlighted in the file storages on this image is quite outdated. We are also could be placed into the off-chain data protocols, as our IPFS and Filecoin solution is off-chain data storage. And I will also tell you that we are, first of all, we are also our own layer 1 blockchain, but we're also developing smart contracts, which are coming later this year, so that you can have all the smart contracts and EVM compatible virtual machine as well on the Filecoin itself. And in the next 25 minutes, I will tell you more about files and folders. And believe me or not, they're not as boring as you may think. So let's start with an IPFS. IPFS is interplanetary file system. So you all are obviously familiar with file system itself, which are just files and folders. But what exactly is interplanetary? Interplanetary means that it is distributed on the first place, that there is no central server, and it is resilient and offline first. Why does that matter? Imagine we are expanding to different planets. We as humanity grow, start to colonize other planets. And if we continue to use the same centralized solutions as we have right now, in order to have some communication with an internet on Mars, for example, whenever you request a file, first the request has to travel all the way down to Earth and then return backwards. And this takes at least an hour for any kind of request. So it's not a very scalable solution as soon as you start thinking about upgradable internet. Instead of that, if you can create a solution where content is already fetched by someone else on Mars, and you can just request that content from him instead of requesting it directly from the centralized server on the Earth, that makes things way more convenient. And you just need to have at least one copy somewhere close to you so that you can always retrieve it without depending on a centralized solution. And that's exactly what IPFS do. IPFS is distributed by design. There is no central authoritative service which is storing all the content. Rather, a lot of nodes of IPFS network are storing bits and pieces of the content which you can request at any point of time. So how IPFS works? IPFS does multiple things. And first of all, it addresses the content by what it is instead of where it is. And let me provide a great example for that. Imagine you're requesting a book from your friend, just a regular physical book. Instead of him telling you what exactly book you have requested for maybe a recommendation to read, he just tells you, okay, if you want this book, you can just go to library, you can go to the second floor, you can go to the third bookshelf, and on the third row, there will be a third book, which is what you're looking for. Then you have to travel all this time. You have to go to this library, to the second floor, to the bookshelf. Then you pick up a book and see that it is the same one as you have in the backpack all of the time. And that's exactly what content addressing do. It's the same thing where instead of telling you what you're looking for, it tells you where it is. And that's how, for example, our computers work right now, where in order to find a file, you need to provide a file path for it. It's also the same way that Web2 operates right now, where in order to find some content, you go to a domain website, you go to a path on this website, and you go to index.html link where everything you're looking for is located. IPFS replaces this whole structure with the content identifiers. So what it does instead of pointing you to the address where a certain thing is located, it provides you the content ID, which points exactly to the object which you're looking for. And the beauty of it is that you don't need to know anymore where your content is located. You can just ask this content ID over the whole network, and the closest peer which has your content will provide it to you. And let me explain you a little bit more how the content ID exactly works. So first of all, content ID is designed to be just a cryptographic hash function, which is implemented in the existing SHA-256 algorithm, and it encrypts it transforms any object or content, which you have, for example, a text file, hello world, into a content identifier, which is associated with exactly this item. And what does that mean? Is that for any content, there is, first of all, created a unique CID content identifier. You can imagine it as a unique fingerprint. And it provides you with multiple functionalities. First of all, for every time you do the SHA-256 on the same content, it will be the same CAD. It's not dependent on IPFS specifically. Anyone in the world can create the CAD, which will be the same for every content, and you just need the original content to produce it from. And the beauty of it is that you can also, once you retrieve some file from the network, you can verify that you retrieved what you were looking for on the first place. So you can create, and again, the SHA function on top of the content you have received and compare with what you have received on the first place. If CAD is not matching, then there is some problems in the network in the first place, and you know that you're dealing with untrustful system. It also works with the folders in the same way it works for the files. So folders, in essence, is just a special kind of a file which lists other files in it. So all the core principles to remain the same to the folders. You can create a CAD for the folder as well. And let me show you how it all works in a system. So imagine you have multiple folders and multiple files inside of it. You'll see on the image that there is, and every folder and every image has an associated fingerprint with a different color. It all will be a CAD, so it's a cryptographic hash function, but all these are pointers to this specific content. So on the first place, you have two folders. One contains 3 items, and then the second one contains 1 item. Then you have a second folder which points to the 2 folders, and then you have the root CAD which points to the original folder in the system. And to accommodate all this information, we have the specific Merkle DAGs, which are graph data structures, and where each node is content addressed, and you have CADs all across the point, so you can trace whenever you point to something. And the beauty of designing the system like this is that whenever you create a new folder with the content which already exists on the network, you create a folder by itself, but the content to which it points inside is already existing. So therefore, first of all, the CADs will be the same. And secondly, you do not need to store the same information again in the network. It will just point to the original nodes which already store the data. By that, you can, first of all, deduplicate the internet. So instead of storing hundreds and thousands of the same content all across the internet, you can just store 5 to 10 copies, which will ensure a retrievability at any point of time, and then securely delete all the other content. And imagine that we have hundreds of thousands of memes stored all across the internet, and because they are addressed by the location, we don't exactly know where they are stored. We rather just know the location. Instead of that, we can point to the exact CAD of the meme and deduplicate and save a lot of storage for all the content being stored on the internet. And you can also do the verifiability, which I already talked before. So this is how it works in one single place on one single computer. In order to create a system out of it, we need to have, first of all, peers. Peer is a node in a peer-to-peer system which operates with IPFS. And we need to create a network of peers, which is Swarm. And in order for the system to work and in order for node to be part of the IPFS network, it must be, first of all, discoverable. So we need to be able to discover the node in the IPFS network. We need to be able to point that certain node stores certain information. And then we need to be able to route the node. What that means is that we need to have a path from our personal node to the node we are looking for in order to have the ability to trace and retrieve the information from it. These are 2 essential points of it, but there are many more that comes in the peer and content routing whenever you dive deeper into the how IPFS and generally peer-to-peer networks work. Secondly, in order to also manage the content inside the systems, there is the very smart idea of using distributed hash tables. Distributed hash table essentially stores or lists all the content which a certain group of peers is storing. And you can imagine it as a very simple example of a phone book. Imagine you have a phone book where you store a name and a number as exactly on your phone, but instead of maintaining it by yourself, you maintain it with a group of friends. And what that brings is to you as benefit. First of all, you do not need to add duplicated solutions. And if someone of your friends already added your friend's name or someone's from his friend's name, you don't need to add it again, but rather you just look through the phone book and retrieve the information which you are looking for. And it is exactly the same how IPFS network works. In addition, we never store the whole DHT table of all the content on IPFS. Instead of doing so, we maintain smaller distributed hash tables for a group of peers, which are storing similar CIDs in the nearby location. By that, we reduce the effort to query the DHT table, but at the same time, we allow to effectively locate where the content is located, because we group the similar CIDs together and they are stored in a similar location, so that we always know where to ask by peer for a certain content, but we are not storing the whole DHT table in one single file. And we also enable all the peers in the network to do multiple things with the DHT table by itself. So first of all, peers are able to add rows to the DHT, declaring which peer ID provides which CID, and we are also telling how to connect with their peer ID. Peers can query the DHT to find peer ID, and they can also query to find a certain content ID. By that, the whole network is capable by itself to find the content over the network, locate at which peer it is located, and request a certain information. That's how simple, but also how generally peer-to-peer networks work. And how to use that in the wild. So let's say you have some content and you want to upload it in a peer-to-peer network so that your content is stored reliably and accessible to you, but at any point of time. So, but in general peer-to-peer network, if there is no nodes, there is no retrievability. So who runs peer-to-peer nodes and why? So first of all, you can obviously run your own node and upload all the content to your IPFS node. You can run it very easily. Already browsers support natively some of the solutions, or you can, for example, run IPFS desktop to do so. But whenever you upload it to your IPFS node, it's only stored locally. And that's the same single point of failure. So how to do that on scale? You can run the network of nodes, and you can also run an infrastructure to manage it. You can also pay a pinning service to pin the content to the nodes, such as Pinata, Temporal, and Fura, the projects which are existing right now. And lastly, you can hope that your content becomes popular enough so that other nodes will pin it by their goodwill. And does that sound to you that we are really in decentralized and reliable Web3, where we have to rely on someone's goodwill and trustworthiness to store the data and make it available to you? Not to me. And that's exactly where the Filecoin comes into place. The Filecoin incentivizes persistent and verifiable storage, which is designed for Web3. First of all, it uses all the same properties of the CIDs, which I was talking to you before. So it's compatible with IPFS and Web3 in general. It uses verifiable storage via cryptographic proofs, so that every storage provider has actually to prove in every 24 hours that he still stores your content, and it will be available to you whenever you request. And it's also a self-managed solution with an open market of storage deals, which ensures that the pricing of the storage is always as low and as competitive as possible. And it works quite simple. So whenever you have a file on the IPFS network, you can use it to create a Filecoin deal. You provide the CID, and in the open market, storage providers that compete to store your data. First of all, you then make a Filecoin deal, and Filecoin deal is an agreement with a storage provider that he will store your data for the duration of the time which you have agreed. So you can, first of all, do multiples deal at the same time. At least we are recommending using at least 5 deals, and all of our storage helpers are using 5 deals minimal, so that all your content is persistent over time. And if something happens with one of the storage providers, you can still find the content and retrieve it whenever you need. You can also do the Filecoin deals repeatedly, so that whenever you request a file and the duration of the deal is maximum 18 months, you can renew the deal automatically, so that this would be duration of the storage for whatever timeline you need. You can also do that in parallel with other solutions such as cloud or other permanent options available in the web, but we are also agnostic to all the other storages, and you can use directly from cloud to IPFS or any other solutions in parallel to ensure the redundancy and your content persistence. And I would say that IPFS is truly loving Filecoin. They're designed to work to be complement to each other. IPFS is here for fast, flexible retrieval. It provides you with the gateways, with the local nodes, with browser accessibility, and Filecoin ensures the persistence and verifiability of your content on the network for the lifetime. So summing up all that, we have the IPFS and network working together, but how to start with it. And that's exactly where I will tell you about the tools for Web3, which are available to you for IPFS and Filecoin. First of all, there are multiple layers of Web3 which are working and dependent on decentralized solutions. First of all, you have always some kind of front end, which is traditional Web2 or newly emerging Web3 front end with web apps, data solutions, NFT or dApps. Then you have your smart or logic layer with standard application logic or smart contracts. And then you come to the storage layer where all the content from the first two parts is stored. And we always suggest to use storage helpers in order to work with IPFS and Filecoin nodes, because they simplify a lot all the deal-making process and generally managing the content on your behalf, but at the same time gives you the flexibility of and easiness of two lines of code collaboration with the content by decentralized storage. And first of the solutions for many of you that might be one of the easiest jumpstart for your personal project on this hackathon, we have the NFT.storage available for everyone, where NFT could be stored with two lines of code with a simple API and a very nice UI website, and you can call the NFT.storage to store any kind of content on the network. It's also backed up 5 times in the IPFS and Filecoin network by it, and you generate the CAD of the content on the fly with this solution. The beauty of it that it's also completely free to use. We treat NFT.storage or NFTs in general as a public good, therefore it should be available to everyone at any point of time. And we apply the same logic to NFT.storage, so you have the capacity of unlimited storage for any kind of NFTs through IPFS and Filecoin to store your content reliably through the lifetime of the content. If you have a more generalized solution, there is also available general free Web3.storage. It's also designed to be a general storage helper for Filecoin and IPFS network. It has a similar interface to NFT.storage, but it provides you with a production level storage and retrieval reliability plus performance. You do all the same, you have all the same interaction. There is only 2 lines of code to change to store with .storage solution. You need just an API key and calls of the libraries, and Web3.storage provides you with 1 terabyte of storage for free as well. If you're working on the websites and you want to develop your website in a decentralized manner and be independent of any specific cloud provider, you can also do that with IPFS. There is a Fleek hosting solution which provides you with a fast, modern, censorship-proof website development, and you can host web apps directly on the open web. It works with the most modern frameworks such as Docker, Gatsby, React, and many, many more. And the simple way to work with it is just to connect a GitHub repository, add the build settings, and it will automatically deploy your website to IPFS, and it will be backed by Filecoin. Therefore, you ensure that your website stays in the place regardless of the cloud providers, and it's actually independent of one single point of failure, which is amazing. One last thing to highlight as a tool is PowerGate, and it provides you with a wrapped container around IPFS node plus Filecoin node. It's a little bit more extended solution where you can manage your own stage storing and retrieval data information, and it provides you the powerful ways to connect and instead P2P, IPFS, and Filecoin solutions. So if you're diving deeper into working with IPFS and Filecoin, have a look at this solution and feel free to use it. And one more exciting thing to mention, we are also making our effort to make Filecoin verifiably sustainable. So there is more information also on the Filecoin Green project, which allows you to understand better how Filecoin network uses the energy when storing your data and how green the energy is. There's multiple consensus mechanisms involved, which allows you to ensure that your data is stored in a green way and it's stored verifiably green. And we provide you with different models and dashboards in order to trace that information. So here is a little bit highlight of what tools can be used for you during this hackathon. Just a brief overlook, feel free to scan the QR code right now. And I will also provide that back in the channels on the IPFS Discord. Oh, sorry, not in IPFS Discord, but on ETH Global Discord. And these are just the highlight of the tools. So there is an NFT.storage, there is web3.storage, there is Fleek, there is Textile Powergate, and there is Lighthouse.storage solutions available to you at any point of time. Also, a quick reminder that for our challenge, it's actually very, very simple to use to participate in our challenge. You just need to develop a solution which uses IPFS for content addressing and Filecoin for decentralized storage. And you can use any of the previously mentioned tools that builds on top of IPFS and Filecoin, and you will qualify for our amazing prizes. And taking a bit of time in the end to also provide you with some ideas for the hackathon projects, especially for those of you who haven't yet decided on what you're going to build. There are many, many ways how you can build with IPFS and Filecoin together. First of all, you can continue or you can develop user and client interfaces with providing information and resources to end user, and you can build that on top of Filecoin. You can also develop smart contracts, which are ensuring the decentralization of the logic layer and providing you the flexibility of operating the specific tools rather than relying on one single solution as a whole. You can also develop with IPFS and Filecoin the compute and consensus layer. Have a look at libp2p libraries. They provide you all needed tools for building your own solution in a truly decentralized manner. And we have libraries that allow you to do so on the fly with a very, very easy way. And you can also develop solutions for hardware and networking. Have a look at the CAD Gravity project. And there are many more that comes into the place when you talk about IPFS and Filecoin ecosystem. To highlight that, IPFS and Filecoin is a scalable storage for the next 1 billion of NFTs and the metaverse. We see already huge potential and huge interest in building solutions for ticketing, for gaming assets, for music industry, for videos, AR, VR. There's also a load of storage for documents and POAPs. And here are some of the project ideas which I think would be very valuable for the participants. For example, for this specific Hack Money project, first free might be the most interesting for you, but I also looking forward to see all kinds of projects from you on the submissions. So feel free to use your creativity. But let's cover a few of those. I definitely see there is a huge potential in managing the art and finances, which happen in the background. We can inbuild into the NFTs the royalty process and smart contracts to manage the art, managing exhibition, lifetime artwork capitalization could all be powered by IPFS Filecoin and also be reliably stored through their lifetime. You can also do an amazing work with DAOs. DAOs are booming right now, but there is still lack of tooling to properly manage them. So feel free to look into the solutions to govern and record DAOs' most important information for the IPFS and Filecoin. There are much, much more on the idea project, and I hope that just gives you a little bit of, oh, this is also possible with us. So whenever you have a question how to implement certain projects, feel free to reach us on Discord, and we are more than happy to help you with brainstorming or helping you with developing your own solution within our ecosystem. So then I will just highlight to you a little bit of the possibilities which are coming together when you're joining our ecosystem. And our ecosystem is the strongest asset in the growing Filecoin network in Web3. On one side, we are seeing the rapidly expanding capacity storage of the network. We have right now more than 4,000 storage providers across the globe, and there is more than 18 XP bytes of total storage capacity available for you. And on the other side, we see an increasing demand of explosively growing ecosystem with more than 330 startups from pre-seed to Series D. And there is more than 9,000 developers contributing to our project at any point of time all across the world. And IPFS and Filecoin is more than just storage. We're also developing solutions for the compute layer of the Filecoin. We are enabling programmability via Filecoin virtual machine, which will be an EVM compatible solution. And there is more coming to that closer to the end of the year. Feel free to follow our updates. And we're also developing solution to ensure verifiably that Filecoin is operating completely green and sustainable. And all this come to build a sustainable foundation of the Web3. So we are looking for your contributions to jointly develop the projects on IPFS and Filecoin. As we're quite sharp on time right now, I'll just highlight some of the projects which are already using IPFS and Filecoin. There is a variety of projects and applications which you can find. For me, the most personally exciting projects are some which are Internet Archive. We are actually backing up the whole Internet Archive right now so that all the content and most humanities important data is available to you at any point of time. There's an amazing and valuable project by Styling Lab, which ensures that historical events such as Holocaust information is persistently stored and reliably accessible to any human on this planet. There's also practical applications such as Huddle, audios for music, or Live Peer for video streaming. And we have some interesting applications on the real world on the open data from the cities. For example, we're collaborating right now with the New York City on storing all the open data together with IPFS and Filecoin. And when it comes to the NFTs and general applications, we are also in the back end of all of the solutions that use NFT marketplaces. For example, OpenSea is also developed by IPFS, supported by IPFS and Filecoin. To sum it up, Web3 is an amazing opportunity to develop your own project, and there are multiple components that brings together the Web3. First of all, the decentralized solution, a decentralized web, it's blockchain, it's linked data, and fairly the best way to predict the future is to create it. I truly aligned here with LNK, and I wish you all good luck on this hackathon. Build your projects, don't be shy, and make sure that you're excited all the way through the hackathon. So I'm wishing you all good luck. And just to come closer to the discussion and the Q&A, feel free to join our ecosystem. There is a Discord and Slack available for you at any point of time. And if you're building our projects in our ecosystem, feel free to ask any questions in the Slack and also in Filecoin Slack with the field builders. After you continue with the project development, there is also micro grants and grant support available, and we are also supporting the ecosystem with by being a developer and sponsor of many projects, and by investing them on the stages of during the different stages of foundation of a startup. So once again, I'm super excited to see your projects. Thank you a lot for attention, and I will now drop to the question part of our talk. And as I see now some of the questions, is it okay that we are, I will spend a bit of time to the questions as well?
Yeah, we can spend a few minutes on the questions and then we'll move it over to Discord after, just because we are running out of time. But yeah, you can try to take as many as you can quickly, and then any questions anyone has, they can take over to the Discord channel we have.
Amazing. Thank you a lot. Then, yeah, totally. I will share the slides about it in the Discord afterwards. And yeah, excited to see people working with IPFS and Filecoin. I know that there are many people who are using it from project to project, and definitely looking forward to your project submissions after on the end. The next question was, who pays the money for Filecoin? I'm not sure exactly to what this points for, but as you see for the whole ecosystem, there is definitely an interest in Filecoin and in this general data layer of the network. And we are designed to be agnostic to whatever systems available on the internet, so anyone can freely plug and use IPFS and Filecoin without any demand. One more question was, is it possible to make temporary user profiles in the IPFS that can be used as authentication for users signing with NFT token address? So it will stop from the same user from signing in multiple times on the dApps. IPFS essentially is designed to be a storage layer, if I understand the question correctly, but you can use CADs as pointers to specific users or to specific NFTs. So any NFT in its internally is a CAD pointer, which, for example, OpenSea or any other solution uses. So this CAD becomes your pointer to the content. If you want to use the same solution to the user profiles, you can freely do that as well. So I think there is a lot of opportunities how to implement user profiles within IPFS, though you need to keep in mind that CID is always unique to the content. So if you want to update your profile or do some different solutions on top of the user profiles, then you have to keep in mind that CID will be changing. And I think that was it on the question side. So I'm also super happy to give back to the stage. And
Perfect.
Thank you all once again for the attention. And I'm looking forward to the amazing hackathon and your submissions. Good luck.
Great. Thank you, Konstantin. Thank you everyone for joining us. I'm sure it was very informative because a lot of people are going to be interested in incorporating IPFS and Filecoin into their projects. We do have another talk starting at 12 o'clock Eastern time with Redstone, unlocking DeFi potential using Redstone cost-efficient custom oracles. If you do have any questions regarding this talk, you can take it over to Discord and the team will be happy to help. Thank you everyone for joining us. Thank you, Konstantin.
Thank you a lot as well. It's an amazing stage.
Have a good